All right, so the next topic is ArrayList. Now this is also in chapter 5. The iterators were in chapter 5. That's where we just use the scanner class to look at the has next and then next. So now we're going to talk about the ArrayList. An ArrayList object stores a list of objects and is often processed using a loop. The ArrayList class is part of the java.util package. You can reference each object in the list using the numeric index. An ArrayList object grows and shrinks as needed, adjusting its capacity as necessary. So this is something important to remember. We're going to talk about arrays in chapter 8. Now, ArrayList and arrays differ. An ArrayList will grow and shrink, or an array will stay whatever size it was declared to be. Index values in ArrayList begin at 0. So if you have a list of string objects, the first one is going to be at index 0. The next one will be at index 1, then 2, 3, and 4. And then here are all the strings that are inside of this ArrayList. Elements can be inserted and removed. The indices of the elements adjust accordingly. So here are some methods on the ArrayList. We have the add method, and we have another add method. In this other add method, you specify the index of where you want to add the object. You have the remove method. You have the get, you pass in an index and you get the object out. Then you have the is empty. It returns true if there's no items in the array list. And you have the size, which returns an int, which indicates the number of items you have in your list. The type of object stored in the list is established when the array list object is created. So you're going to use the less than and greater than signs to specify the type of object that you're going to store in the list. This makes use of Java generics, which provides additional type checking at compile time. An array list object cannot store primitive data types, but that's what wrapper classes are for. It's important to remember this because in chapter 8, we're going to talk about arrays. And in arrays, we can use primitive data types. And here they give you an example of the array list. You can go through it if you want, but I'm going to do my own example. All right, so to demonstrate ArrayList, I'm going to go ahead and hop back to this example where I'm using the scanner class to read that file of songs. So the first thing I want to do is I want to demonstrate an ArrayList using strings. So we want to use an ArrayList. We just use the type ArrayList. And as you're typing out, you can see IntelliJ is telling you to use the ArrayList here. I'm just going to hit enter. It automatically imports it for you. And then we're going to specify the name of our list, but you also have to specify the type of data that you're going to hold. Then you instantiate your list. Now you don't have to specify your type here. You can, but it's redundant. You can see that IntelliJ has graded out, meaning that it's redundant, doesn't need to be done because you've already done it over here. So we can just leave that empty if you want to, or you can just put a string in there if you wish to have it there. So the reason why I wanted to create an array list is instead of actually printing all this information, I want to store all this information into a list. I'm going to come right here where we're printing everything out, and I'm going to go ahead and just insert it into our array list. So to insert an item, you just hit add, and then you pass in the string that you want. So I went ahead and removed the system out statement, and I just made a string, and I'm just adding it into my list. And then down here, I can print out my list. I'm going to print it out using the for each loop. So this is what I did. I'm just creating a for loop, and I'm just iterating through that loop and just printing out the same information. So it's not going to look any different than what I had before. But let's just go ahead and run this program. Since I printed this out, I just realized that we have an extra new line space. I'm going to go ahead and remove that. That's actually happening right here. So I'm passing in the string into a list, but I don't really want to take in the new line because whenever I'm printing this out, I'm printing it out to its own line. So I'm going to go ahead and rerun this program. And there you go. It looks just the same. But one thing that we can do with an array list is we can sort them. So if your array list contains an object that has the comparable interface implemented, then you're able to sort your items inside of your list. You can use the collections class. There is a class called collections that has static methods, and one of those methods is sort, and we just pass in our list, and that's going to sort our list. So let's look at our list currently. Our list started with Like a Rolling Stone by Bob Dylan and then Satisfaction. Now I'm assuming this list is in order of which is the top songs. So they're saying that this song right here is number 1. Now we didn't actually capture any of that information, but when we sort this, we're going to sort it the way the string sorts it. So all of these characters are the same until you get to the name of the song. So it's going to be sorted by the name of the song. So let's go ahead and run this. As you can see, just by looking at our bottom results, it did sort by the name of the song. So at the very top, I expect to see songs with symbols in them and then numbers and then the letter A and so on. So there's other methods you can use on the collections class. So like once we've sorted it, we can reverse it by just using the collections method to reverse. And this basically just puts it in backwards order. So if we sorted it, then reversing it would put it the other way. So you can see at the top of the list, we have our songs with Z. All right, so let's take a more object-oriented approach to this. So what we're going to do is I'm going to go ahead and create a class that's going to hold a song, the artist, and the rank. And then we're going to parse out this data and put it into that class. So what I'm going to do is I'm going to come over here. I'm going to make a new class. I'm going to name this class song. I'm going to give it data for rank, for name, and for artist. So here's my instance data. I'm going to go ahead and auto-generate the constructor and the getters and setters. All right, so I auto-generated the constructor, the getters and setters, and also the toString method. So this is just a pretty standard class. So I'm going to go ahead and hop back over to my driver class and then put my song objects into the array list. So I'm going to come over here. I'm going to change this from string to song. I'm going to hop down to where I'm adding it to the list. And instead of adding a string, I'm going to add in a new song object. So here I'm passing in a new song object into my array list. Now I'm getting a rank. I went ahead and created an integer called a rank and I set it to 1. So I want the first song to be at rank 1. And then when I insert it, I'm doing a plus plus at the end of this. So this is a post increment. So that means the next iteration, it's going to be a 2. But while I'm putting it into the song object, it's going to be a 1. Then I'm doing a scan.next, which is going to be the name of the song. And then a scan.next, which is going to be the name of the artist. And if you look at the way that my constructor is set up, you take in the rank, the name of the song, and the artist. So now that my list contains songs, this right here is upset at me. Let's hover over it and see what it says. Okay, so it's letting me know that we don't actually implement the comparable interface on this song class. So that's something that we're going to have to do if we want to sort. But we're not going to sort it for now. Let's just go ahead and comment this out. And we're going to go ahead and do a for loop for song. And we're going to output the song. And this is going to call our toString method. So let's go ahead and run this. And you can see here are all my objects. The number 1 song is Like a Rolling Stone. So these are all the songs ordered by rank. That's the way they appeared inside of the file. If I wanted to sort this a particular way, I'm going to have to implement the comparable interface. So let's hop back over to song. So this is the way we implement the comparable interface. We're going to say implements, and then we're going to say comparable. And as you're typing, you can see there's 2, comparable and comparator. You want comparable, select comparable, and press enter. So when we implement the comparable interface, it's always best to specify what you want to compare your song to, right? So we're going to come over here, we're going to put the less than and the greater than signs. And inside of this, we're going to put in song because we're comparing ourselves to another song, right? So this is implementing the comparable interface. We're going to compare to another object of the same class. So there's a red squiggly line, hover over it, click on implement methods. There's only one method to implement, and we're going to go ahead and implement this method. Now remember from the lecture, if the object that is having the compare to method invoked on is considered to be less than the object being passed in, then it's going to be a negative number. If they're equal, it's going to be 0. If it is greater, then it's going to be a positive number. I'm going to go ahead and write that in. So essentially all we're going to do is just compare the names of the songs, right? We're not going to do anything else, and that's going to return a negative, a 0, or a positive value. So now when I hop back over to my driver class, so let's go ahead and run it. And you can see that these are sorted by name of the song. Now, if we wanted to sort by the name of the artist, we can simply go back to our song class and change the compare to method. And that's exactly what I did here. So let's go ahead and run this. And you can see that all these items are sorted by the name of the artist. Now this artist has a question mark in front of it. And then there's some songs by AC/DC. And then like there's songs by Aerosmith. You can see that it's all sorted by the name of the artist. There is kind of a problem with this compare to method. If I wanted to sort by an artist, I'm having to come and just completely change my compare to method. Or if I want to sort by rank, I'm having to do the exact same thing. Well, the first thing I want to do, I want to fix this to where I feel like the compare is correct. Whenever we compare these songs, I always want to compare by name first, because to me it just seems right to sort a list of songs by the name of the song. If the names of the songs are equal to each other, then I want to sort by the artist. So I'm going to go ahead and set this up. It's going to be pretty simple logic. And here's the logic that I'm using. The first thing I want to do is I want to capture the result of the compare whenever we compare the names. Now, one thing that we didn't take in consideration is for case. So the string class actually has compare to ignore case. So I'm going to go ahead and implement that. So I implemented compare to ignore case for both the name of the song and the artist. So if the names of the songs are equal to each other, this was going to be a 0. Then I'm going to compare the artist. To me, that's a proper compare. If you look back at the collection sort and just click on the different methods it has a method where you can actually pass in a comparator. So we can create our own comparator in our song class so that we can use them to compare songs based on artist or based on rank. So I'm going to go ahead and set that up. So your inclination might be actually to implement the comparator interface up on the class header, but a song shouldn't really have a comparator. A song is actually something that you pass to a comparator. But we want to associate this comparator with the song class. So what we can do is we can make an inner class inside of our song. So I'm going to go ahead and make an inner class that is going to implement the comparator interface, and we're going to make one for each type of compare we want to do. So this is going to be something different, okay? But it's just something that you can do in order to make your class more usable. So within the song class, I'm going to make a public class. I'm going to call this one artist comparator. It's going to implement the comparator interface, and then we're going to click on implement methods. And the only method we want to implement is compare. Now there were these other methods, but the only one you have to implement is compare. So basically what we're going to do here is we're going to come up with some logic to compare two songs. And since this is an artist compare, we're really just going to compare the names of the artist. And if the names of the artist are the same, then we're going to compare the names of the song. So we're essentially going to reverse the logic that we did up here. And here's what I did. I just got the result of comparing the artist. If it's equal to 0, then I'm going to return the result of comparing comparing the names of the song. If this is not equal to 0, I'm just going to return this result, which I need to fill in. I left it 0, and it's going to return that result. So I also want to make a comparator for comparing rank. Okay, so here's what I'm doing for rank. This is how I set up my compare. I have my 2 songs coming in. If song 1 is ranked 1 and this one's ranked 500, the difference between these two is like -499. So this would be a negative number. So that just means that object 1 comes before object 2, which is the correct result. But for some reason, let's just say that the results are equal to each other. I don't expect this to happen. I expect like everything to have a unique rank. But let's just say that 2 things are ranked the same number. Then this is going to be 0. Then we're going to check the name of the song. If the names of the song are the same, then we're going to check to see the names of the artist. But if the names of the songs are different, then we're going to return the result of this compare right here. But if they're equal to each other, then obviously we're going to return the compare of the artist. So I have these 2 comparators inside of here. I know it's a little different to have a class inside of a class, but we're going to use these comparators in order to specify the way we want to sort in our driver class. So we're going to hop back over here. So if I were to run this program, you can see the list is sorted by song name. Now, if I wanted to sort this just by artist, I would come into my collections and I'll say new and then song artist comparator. Now this is red. Now the reason this is red is because I forgot to do one thing. I'm going to hop back over to my song class and I forgot to make this static. Okay, so now it's happy. So let's go ahead and run this. And you can see my top songs are sorted by the artist. Now, for some reason, I wanted to sort by rank. Then I can just come over here and change this to rank. And now you can see that my songs are sorted by rank. I'm going to make a menu to make this list a little easier to deal with so I don't have to sit here and keep changing this. So I'm going to make a menu like we've been doing. And I'm going to ask the user, how would you want to sort the list of songs? And they're going to enter in a value, and that's how I'm going to sort. All right, so here's what I did. I went ahead and made a new scanner that's going to listen to the keyboard, and I made a char that's going to hold the option that the user enters. Then I went ahead and made a menu in a do loop. So the do loop is controlled by a while, and the while is not Q. So I went ahead and gave the option enter 1 to sort by rank, reverse rank, name, reverse name, artist, reverse artist. Now I have them enter 1, 2, 3, 4, 5, and 6 because I couldn't think of clever characters for each choice, but I am treating these numbers as chars. So it's going to get stored in opt, which is a char, and then the switch is going to examine that char. So if it's a 1, it's going to do this sort right here for the rank, and then if it's a 2, it's the reverse sort for the rank. So it's basically going to sort by rank, but also reverse it after it's done. And it's going to do the same thing for the name, except it can sort by name. Now remember, our normal sort is done by song name, so we don't need to pass in a comparator. And then we're going to reverse it if the user decides he wants to reverse it. And then we have our artist compare where we just pass in the comparator, and then we do the reverse if the user wants it in a reverse order. Now I did make this static method called print song list, which takes in a list and essentially just takes in an array list of songs, and it just does the for each loop and prints them all out. Now I'm printing them out like this instead of using the toString. I just think it makes it nicer to look at. So let's go ahead and run this program. So at this point, the program read the file, loaded everything into the array list, and now it's giving me a menu to interact with that list. So the first thing I want to do is I just want to see all the songs by their rank. So I'm going to enter in a 1, and here are all the songs by rank. So right away, one thing I don't like is I want the rank to take up at least 3 digits. I'm going to change this to a 3, so that means it's going to take up 3 digits. I'm going to go ahead and rerun this program. All right, I'm going to enter a 1 to sort by rank. All right, there you go. So it looks a little nicer. And here are all my songs ordered by rank. All right, so then I'm going to look at the menu and I'm going to sort by artist. So I'm going to go ahead and enter in a 5, and all the songs are sorted by artist. The artists are actually in order. The ones that start with the W are at the very bottom, and then up top we have artists that start with numbers. Okay, and if I wanted a reverse sort, I can go ahead and put in a 6. So now I have the artists that start with numbers at the bottom. Or actually, I said numbers, but it's actually this question mark, and then it's the A. Okay, so if I want to just sort by song name, I'm going to put in a 3. And if I want to reverse sort by song name, I'll put in a 4. And you can see it's just using the collections to sort this list. As long as they have the comparable, it's able to sort. And then if I want to do like custom sorts, I can just create comparators. Now remember, comparators should not be an interface that you put onto a blueprint class because it's simply just comparing 2 objects. It is something that you can put into your blueprint class because it's associated with your song. So we have a class within a class. I made this class static, and whenever we want to use it, we just create an instance of this rank comparator or create an instance of this artist comparator. And it's simply just using this compare method to figure out which one is greater or which one's less than. So that is all I wanted to talk about for ArrayList. So we actually know a lot of stuff to do some pretty powerful things. We can use interfaces so that we can do comparables. We can put things into ArrayList. We can sort them. We can read things from files now. So now that we know these things, we can make interesting and better programs.